Greetings, Augies worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with Trevor Ullman, our Ask Dave editor, and we're going to go through some Ask Dave questions. What's the general subject today, Trevor?
General subject today is making some connections that people are having trouble with.
Okay, well, let's see what we've got.
All right, so Will asks a question about whether or not a wind turbine is a good idea for him.
Well, he likes my solar setup, and I've got a new solar panel I just got, and I was building a battery box today, and when I get all that finished, I'll make a little video about that. Have I given any consideration to wind turbine? The problem with the wind is normally the wind is highly seasonal and blows generally in March and April, and that's about it. Otherwise, we have very little wind here, and even the wind we get in March and April is very gusty, followed by periods of calm. So it would not be economic to put up a wind turbine. Also, you know, if we lived in Wyoming or someplace like that where the wind blows all the time, definitely it would be a thing to do. But we do have lots of solar. We've got lots of light, so that's what I'm doing here.
All right, Ken, call sign AE1E, wants advice on a rural, high elevation, windy site for an antenna. So
he's in a rural place and it's very windy, and he wants to put up an antenna. And it's looked like he's lots of space. Well, the problem with high winds on those trees, of course, is that they can move the tree, which can snap an antenna in a heartbeat. There is a technique where you put the rope over a pulley coming down to a weight. So if the tree moves like this, it just causes the weight to go up and down. Those can still cause issues because if you get the right bend at the right moment, you can still snap that antenna wire. But if you make that pretty stout and do it with a pulley and a weight, that's one way to help with those wind. He is leery of rotatable beams. You can build a tower to any strength you want and follow the manufacturer's guidelines for the very high winds, and they'll withstand whatever you build them to withstand. One of the problems is that most amateur radio beam antennas usually are listed as up to about 80 miles an hour, sometimes not that strong. Now, the highest wind I've ever recorded here is 57, but that doesn't mean 80 mile an hour won't come sometime, but I haven't seen it in 10 years that we've been here.
All right, Mike, call sign K3MSP, is having a few problems. His breaker is tripping on his GFI, and he's having some antenna problems, and he needs help connecting his Kenwood TS440S.
Having an RFI issue which manifests itself in a GFI receptacle tripping. That is no fun. The first thing I would suggest, since they aren't that expensive, is go ahead and replace it. Put in a newer breaker or one of a different manufacturer or something like that and see if that helps. Another thing to do is to keep the RF as far out of the house as you can, which means good grounding for your station with your own dedicated signal ground very close to the ham shack, and try and he talks about making an ugly balun and wrapping the coax around it. Do the same with your power cords, because sometimes you can get emission coming out of the power cord that can be getting into the household wiring. The Kenwood TS440 looks like a nice radio. He's also got an ICOM 7300, which is a wonderful piece of equipment. Yeah, you've got a conducted emissions problem there, so try some hefty large-sized toroids and wrap the power cord around it multiple times and try and keep any RFI out and go ahead and give it a try to see with what happens with a different GFI outlet in there. Homeowners can replace those themselves. Be safe, turn off all the power in the house and make the change. Or have an electrician do that for you. Also check the household electrical ground to make sure that somehow the wire isn't broken. There should be near your utility panel where the wires make entrance into your house is a utility ground. Make sure all of that is in place and that grounding connection is solid. It's frustrating to have RFI problems. There's nothing in particular about the ICOM that causes that. It's just the way the wiring is set up, and you've got something in there that catches that and causes that GFI to flip.
All right. David, call sign KI7JTE, wants help with his installation of a flat copper connection using duct tape.
Cable raceway, combination of plastic sheetrock inserts with holes drilled in the cobble street, double-sided duct tape. Well, you know, you've got a 3/4 copper conduit in the rear of the desk and then a 25-foot length of the 1-foot wide copper strip. You don't need to insulate that. You really don't. You can, of course, if you want to, but the point is that it's at ground potential, so there should be nothing on that. If you want to cover it with duct tape, fine. Duct tape can sometimes be conductive, but yeah, you don't really need to insulate that as that runs down to your signal ground.
Terry, call sign N1QHJ, has a question about his data port on an HF fitting sound box.
My question is he's got a 950, wants to explore digital modes. Question is, with the data port that is designated RIDI packet, I think this is a port for a mini 6-pin DIN connector, but will this port interface with the sound box? The answer is yes. If you're thinking of the Signal Link USB or something similar to that, yes, this is the thing that it interfaces with. That's the one. Very often when rigs are sold, they'll give you the little connector that interfaces with that. If not, you should be able to get that online from somebody like, there's an outfit in Longmont, Colorado. I'm trying to think of the name of it. It's a maker outfit, and they have all of these little plugs and things like that. So just look on the internet. You'll find the one that is right for you. And yes, that is the proper place to connect. There will be audio input, audio output, and push to talk, all available right there on that one connector. Okay?
Frank, call sign K5NMH, is assembling an AR6 Cushcraft antenna.
Okay. If you use a short piece of PVC pipe between the mast and the antenna, should I connect a ground wire between the mast pole and the antenna to make sure everything is grounded? Yes. Or should I avoid grounding the mast part of the antenna? No. You can ground that. Unless it says specifically not to. If it says put an insulator in there. But question 2, there are 2 female connectors on the antenna. One goes to the radio, the instructor. You're supposed to cut a small piece of coax to the frequency you want between 47 and 54, usually just above 50 megahertz is where you want that, and screw it on the second connector. What does the dummy piece of coax do? I don't know. I'd have to look at the instructions for that. It seems kind of odd. It may be a separate connector for 6 meters. 3.5 inches. What if I want to use the lower part of 47? There's no ham bands in the lower part of 47. Will the antenna be unmatched because I cut that for 52? I would say, well, and you're not going to transmit above 55 on that as an amateur radio operator. Usually the activity on 6 meters is closer to 50 megahertz, between 50 megahertz and about 50.5. FT8 is very busy around 50.313, so you can tune for that too. It sounds like there's a stub on there for some reason. Check the instructions and follow them carefully.
All right, Richard asks what the best height for an MFJ 2012 off-center dipole is.
The best height is a half wavelength on the band you use the most. And I suspect that's 40. So if you can get it, let's see, a half wavelength is 66 feet long. If you can get it 66 feet long in the air, 66 feet up in the air, that's great. It's real hard for a lot of people to do that. It's, 33 feet would be good for 20. Try and get it up around 30 feet or so at least if you can. What's going to happen is on the lower bands, it's going to tend to radiate more up. As you go to the higher bands, it's going to radiate down toward the horizon. And on 10 meters, you're going to split the forward beam into two parts, elevation-wise, the same with 6. I guess the best answer for that is put it at the height that's most convenient for you. See how you like it. And if you're dissatisfied with it, you can try different things.
All right. Dan, call sign NORDD, has a question about horizontally polarized antennas.
Mm-hmm. Okay, like dipoles and so on. VHF 2-meter single sideband. Why does everyone insist on using horizontally polarized antennas? Because that's how it's done. FM is done vertically polarized. Everything else is done horizontally polarized. So if you try and use vertical polarization, you're not going to be following the custom, and you may not get any results. This is pure amateur best practice. People who do what's called weak signal work on UHF and VHF use horizontal polarization. It's just the custom. There's no fundamental reason for doing it differently. I mean, there's no engineering reason or anything like that, but horizontal polarization is used for those modes. So if you want to do those modes, you're going to need to use horizontal polarization, which means not a vertical.
All right, Donald, call sign N4CCJ, is stringing a pair of LC 160s and he needs help with that.
Let's see what we've got here. I have a pair of LC 160 traps. He knows that they're for 160 meter dipole. Question is, how are they strung? Are they placed in between two lengths of wire or at the end of the wire? Between two lengths of wire, not at the end. For 160 meter dipole, I'm not going to try to give you exact dimensions for how to do that. You'd have to go look at the instruction manual that came with the LC160 traps and see what it says, because it'll act, part of the antenna will act as an 80 meter antenna and the traps cut it off. And then the rest of the antenna will act for 160 in conjunction with that first half. The question is, how much loading do the traps provide? Because very often they provide a fair amount of loading, so the extra piece of wire for 160 can be much shorter. So that being the case, I would try to get the instruction manual for the LC160s and see just what they say on that. Designing trap dipoles is a bit of a black art. There are design helpers out there, programs that you can use to do them, but you've got to work to get those lengths just right.
All right, Leonard has a question about building antennas and the separation between the antennas on the pole.
Okay. Looking at a quad band radio that covers 10 meters, 6 meters, 2 meters, and 70 centimeters, I might point out that those are FM. Those quad band radios are FM radios. They don't cover single sideband or anything like that. So you could build 4 or 5 antennas, 2 sets of verticals be better. First of all, you're going to find very little FM on 10 meter and 6 meter. There might be some. I have never worked FM on 10 meters, even though there are a couple FM channels up there above 27 megahertz. So his question basically is dual band antennas. You can do, readily available, a 2 meter, 70 centimeter dual band antenna is readily available. In terms of 10 meter and 6 meter, I would suggest looking on the web to see if there are any plans for those. Because you're doing FM, you're going to want vertically polarized. 10 meter half wave antenna is 5 meters or 15 feet. It's not very tall. A 6 meter half wave antenna is 3 meters or 9 feet, closer to 10 feet. So again, not very tall. You can build these antennas yourself, taking into account that the aluminum tubing has a velocity factor in the range of 0.9 to 0.95, and put up an antenna for those. Good luck finding FM activity on either 10 meters or 6 meters. Now, if you live in a big city like Los Angeles or San Francisco or Dallas or someplace like that, there may very well be FM activity on 10 meters and 6 meters. So you can look that up, see if you can find repeaters, find out what the frequencies are, and so on. And yeah, you might get yourself a little antenna switch so you can switch between antennas. I do not know of a 4-band antenna that covers all of those bands. Well, that concludes another session. Thank you, Trevor. And we'll be working on more of these as we go. Trevor mentioned that people are feeling very free to write in with questions, and that's great. Remember, you can pose your question at hamradioanswers@gmail.com. That's hamradioanswers@gmail.com. Also, please check out my support page at dcasler.com/support. There's the tip jar there, a link to Patreon, also some very cool Amazon links that you can go to and find some rigs and test equipment and things like that that you might want to purchase. Until we next meet, 73.